Hello everybody, my name is Krishna.Kishore and today we'll discuss about Docker architecture, and one of the important concepts in the Docker is container runtime. So as usual, let's try to keep it very simple so that even the beginners can understand from the session. So Docker architecture is nothing but the client server methodology. Client server methodology meaning the client is our local computer wherein we run the Docker commands like Docker pull, Docker run, so on and so forth. And the server is nothing but the Docker daemon which accepts the request, processes and serves our requests. So I repeat it. Docker architecture is nothing but the client server methodology, wherein the client is our local machine on which we run the Docker commands, and server is the Docker daemon which accepts, processes, and serves the requests for us. So this is how it looks in the real nature. As I said, so the client is our local computer or the machine on which we run the Docker commands, which from where the Docker daemon or the server accepts the request and processes it. So during its journey, it connects to the external utilities like Docker registry, extensions, plugins, and so on and so forth. Okay, for example, if you see this Docker build, so what are we doing over here? We are creating the Docker image from the Docker file. So this goes to the Docker daemon. The Docker daemon creates the Docker image, yeah, and while building the Docker image, yes, as a base image, we use some other Docker image. So it has to connect to the Docker hub to get that base image. That is the reason. So we see this connectivity. So it gets the base image from the Docker hub, and along with that, the other instructions from the Docker file, it creates a new Docker image for us. Okay, so we have the Docker registry over here as well. So the Docker registry is the one which wherein we store the Docker images and AI models, compose the Docker compose file and other things. So when we click on this, this is the Docker Hub URL. This is the Docker Hub URL. So when we click on this, so this is how it looks. So whoever the DevOps engineer, the developers and others, whoever works with Docker, they should have a knowledge on how the Docker Hub looks like. How can we search for the specific Docker image, which version of the Docker image we go to use in our project. So all that knowledge is required. For example, so let's do with an example. Let's search with the Nginx image. Nginx image. So over here we see there are several types of or the verification what we have. Yeah, Nginx image. Okay, so we have Docker official image verified by publisher and OSS open source projects, yeah, or the images. So the Docker official image is the one which has been verified by the Docker itself, wherein we can blindly test and start using those images. Along with that, there are some um, publisher verification images as well. For example, if I'm developing a new Docker image and I think that it can be used by the others for their work, I can push that image onto this and others can start using it and read that image. So we can see that few images, so few unofficial Docker images have the good ratings and the comments by the users and the publishers. Okay, let's go with the Docker official image for now. So let's click on this and it will search so let's search the Nginx image for us. Okay, in the left hand panel side, so we see the other types or the products like images, extensions, Helm charts as well, compose. So let's stick with the image for now. So let's choose the image and let's click on this Docker image. Okay, so we can see the other details of this image, the type, SHA ID, so on and so forth. What is required for us is that we have to go to the stacks. So the stacks is nothing but the various versions of this Nginx image, right? So various versions of this Nginx image. Yeah. So these are, so it's Alpine 3.23 Perl, Alpine Perl, so on and so forth. So we have several versions of this Nginx image. So this is of size around 33, 34, right? But when you are working with a low configured laptop or your computer, then we always have to deal with the very lightweighted Docker images. Okay, very lightweighted Docker images, so that it becomes very faster in downloading, and it works faster in creating the Docker images, the Docker containers, and your work becomes very faster. So one of the types of the Docker images is Slim. Okay, if we sort, if we filters down with the Slim images, so we can see the difference in its size. So let's search. Okay, if you see this Nginx Slim image is of only 5 MB, 6 MB, right? So for your work, it becomes very faster. So this is the way what I would like to show you how we can search for the specific Docker image in the Docker Hub and decide which particular image we can use for our project. Right. So we talked about Docker client, Docker daemon, and the Docker registry. Let's talk about the Docker objects. So when we're dealing with the Docker, we deal with the several Docker objects like containers, images, volumes, plugins, network, so on and so forth. Let's see with an example. So when we run this command, the docker run -it image and the command, okay. So what does it happens in the background when we? So what are we doing over here? We are creating a container out of the image Ubuntu, out of the image Ubuntu. So what happens in the background? So what all um, Docker objects, or how does the architectural flows when we run a particular command? So when we run this command, so what happens is that initially it checks for the Docker image Ubuntu in the local machine, and if it doesn't find, it goes and checks in the Docker hub, and it downloads and it pulls the image from there. Okay, so it checks for the image initially, and then it attaches low level storage as well for that container to run, and it creates a file system in the container, and it executes the command, which command, and it executes this command when it starts the container, right? So, and then it runs the container, so when we are running with simple commands, so these are the major operations, what happens in the background. So indirectly we are dealing with the, and it also uh, manages the network. So we are dealing with these several Docker objects when we are just executing the one simple Docker command, right? So to summarize it, the Docker architecture is nothing but the client server methodology, yeah, wherein we have Docker client, um, which is our machine on which we run the Docker commands, the Docker daemon or the server, which serves, which processes and serves the request. Docker registry, wherein we store the Docker images, plugins, extensions, AI models, and the compose files as well, and the Docker objects like images, volumes, containers, so on and so forth. So, what is a Docker container? So, what is a Docker container? Docker container is an instance of an image. Docker container is an instance of an image, meaning with this example, you can easily correlate that when we are executing this command, we are creating the Docker server or the Docker container out of this Docker image. We are creating the Docker container from this Docker image. So Docker containers are nothing but the instance of the Docker image. Moving ahead, one of the important concepts in the Docker is the container runtime. Yeah, container runtime, container. runtime. Yeah. So what are container runtime? Container runtime is nothing but it handles the life cycle management of containers. Okay, container runtime is nothing but it handles the lifecycle management of the container. So what is the lifecycle management of the container? Like start, stop, destroy, create containers, and attaching the low level storage, doing some network management, so on and so forth. So it basically handles everything about the container. So whatever the container is required, the low level storage to store some files and the folders and the basic network methodology, etc. Okay, wait, you might be confused over here. Just just before you said that Docker daemon is the one which serves processes the request for us when we run any Docker command, then why do we have the container runtime? Okay, think that container runtime as when we are just dealing with Docker, okay, it is a part of the Docker ecosystem. Container runtime is part of the Docker ecosystem. But when we are dealing with the other tools like Kubernetes, for example, okay, uh, it it runs as a part of the Kubernetes ecosystem, or it can be plugged in or install and set up as an extension. But why do we need the container runtime in orchestration tool? Why? Simple. Over in the Kubernetes as well, we have containers, meaning we have to manage the container. We need the lifecycle management over there as well, right? Eventually, pods will have the containers. So that is the reason we attach or connect the container runtime in the other tools like Kubernetes, the orchestration tool, right? So what I would like to say is that when we are just dealing with the Docker, it is a part of the Docker daemon. When we are dealing with the other systems, wherein we can attach plugin and make it as a part of that software's ecosystem, right? That is the reason Docker has developed this separate component, namely container runtime, wherein the other tools can use it, right? So still confused? Let's try to differentiate between the Docker and the container runtime, right? Just assume that if Docker is a engine, container runtime is turbocharger for us, turbocharger. Or think that if Docker is a house, okay, container runtime is air condition. Okay, what I would like to emphasize and make you guys understand over here is that these these two components might be separate, might be individual, but they work together to serve a particular request. Okay, and this container runtime has been developed by Docker itself, and it has handed over the project to CNCF, CNCF, Cloud Native Computing Foundation. Why? The reason is that the reason is Docker wanted to maintain the uniformity across the market. Meaning, for example, if as we just said that Kubernetes also requires a container runtime, right, to manage the lifecycle management, to do the lifecycle management of the container. Meaning, over there as well, we require some container runtime, right? That is the reason it has developed a separate component and handed over to the CNCF so that the other tools and the softwares, for example, the Kubernetes orchestration tool in this case, require it and can use it, right? So this is about the container runtime. Hope you guys understood. And the default container runtime of Kubernetes is container D. Container D is not only the container runtime what we have in the market. We have other container tools, container runtime tools like runc as well, so on and so forth. Okay, hope you understood about the container runtime. What is the slight difference between the container runtime and the Docker? To understand more about it, let's see the key features of the container runtime. Right. So one of the features of the container runtime, as we just discussed, is the lifecycle management. Lifecycle management of container, right? Wherein we are starting, stopping, creating, destroying the container. So everything about the container, right? Whatever is required to create the container, to execute the container, to monitor, manage, everything is being done or maintained by the container runtime. And image management, it also does the image management, like pull, push the Docker images from the Docker registry, and um, distributed architecture. So why I say is that the distributed architecture is that, as I just said, this container runtime project has been developed by the Docker, and they're handed over to the CNCF so that the other tools like Kubernetes orchestration tool can attach and use it. So it has the distributed architectural methodology, wherein the others can also plug in extension and use it. And then it is an open source project. Yeah, it is an open source project because, as I just said again, yeah, so it has been developed by the Docker, and they've handed over it to the CNCF for the other systems to make it use. So it is an open source project wherein the others or whoever have an interest can work on it and develop this one, right? And it is pluggable and extensible, right? Okay, when we are not working with Docker, but we, yeah, but if we still need the container runtime for some work to manage the container, we can plug in an extends, install and run it as an extension, right? So this is all about the Docker architecture and the container runtime. Hope it had helped you in understanding these concepts. I'll come up with more concepts of the Docker in the upcoming sessions. Um, until then, take care. Bye.